This webinar will be recorded. We will be sending this out after the webinar. It will also be available on our YouTube channel for drone nerds. And so let's get started. Ilya, if you can go ahead and reshare your screen for us, we'll hop right in and I'll have you kind of guide us as we go. And while we pull that up, we just want to welcome everybody again to this combined webinar, Tech Talk. We're here to discuss softwares and drone data and operations with our partners here at Measure. In this scope of work and in what we're going to be discussing here today, there's more operations that are involving remote stakeholders, and they're unable to travel to job sites, especially at a time like now. And what we're going to do here today is take you through an end-to-end process on how best to plan, fly, create useful data products, and then be able to actually share that information that is captured with your remote stakeholders. We're also going to be sharing a sneak peek here at the end of our presentation into a remote collaboration product that is new to beta testing, and we'll tell you a little bit more about how you could potentially become a part of that beta test. So with that, give me one moment. Here we go. So our agenda for today, yep, go ahead.
Right, we're going to try to fill in for Ben, who is our voice of our product. So this is apologize in advance for any improvisations that'll have to take place. We're going to give it a shot here. Ben, we already miss you. So all right. So the things we wanted to talk about today is a little bit of best practice pertaining to capturing imagery and processing the data and making useful data products using that captured data. Justin will be talking about the mobile aspect and segment of this whole process, and I'll pick up and talk about data processing and making useful data products, and even doing some things after you've created these data products, after the files are generated, as it were, and what else can you do with the stuff. So we'll get into that a little bit. Just to do a really high-level overview of ground control, what we offer is a combination of, think of it as 3 pillars upon which the product stands. If you think about the drone workflow as a whole, you are going to need something to capture the imagery and control the drone, program the drone. Think of it as kind of a drone segment or a pillar. The second is mapping and data analysis. The core products we offer currently revolve around geospatial data products, and also program management. If you have a fleet of drones and you're looking to scale the operations and do things like track people, plan missions, stay compliant, and do everything else with that drone fleet and the data, you're going to need that as well. So today we mostly are focusing on the capture aspect of this, as well as the mapping and data analysis, and we'll leave the program management for another webinar.
And yeah, I just wanted to also remind our participants that at the bottom of your screen, everybody has the Q&A button. We have slotted in today's presentation to actually discuss Q&As after each section, really giving you guys the opportunity to ask those more in-depth technical questions. And that way we can make sure we're answering every question that you have. So again, any questions that you have, please drop into the Q&A box. We will monitor them, and then at the close of each section, I will go ahead and we'll engage in a Q&A live discussion.
Great, thanks, Desiree. Wanted to mention that we're going to try to focus on things to get you up and running, right? So we're going to kind of geek out on this and get a little bit in detail. So feel free to ask the questions. All right, I think that's it for ground control. And Justin, back to you.
All right, so what we're looking at here is the mobile software for Measure Ground Control and specifically the grid flight planning. And this is the type of flight plan you would use for capturing and creating a map. And what we're going to discuss are the things here on the sidebar on setting up this flight plan. We're showing you this through our software, but you can find these things, and these are very common features in most mobile applications that deal with flight planning for map making. So go ahead to the next slide if you would. The first thing we're going to talk about is the overlap settings. This is important. These are important settings. So we have the side lap and front lap, and as you probably already know, the side lap controls the amount of overlap between images side to side, and the front lap controls the amount of overlap between images facing forward. So as the camera flies down that grid row, how many images it takes and at what interval. Typically for overlap, we want a 60% side lap and 75% front lap. Now this is going to be dependent upon the environment that you're shooting. So if you're at a construction site and there's a lot of visual details that will be imaged, you don't need quite as high of an overlap setting. But if you're doing, say, agriculture and you have a lot of field work, a lot of trees, a lot of green, then you need higher overlap settings. And next slide, please. And the reason you need that is so that you can, this is an example of some overlap. This is 6 images with a low overlap. And at the top example where we have these tie-in points, this is how the software processes all these images into a single data product. So what it's doing here is it's looking for these unique visual indicators that it can use and find throughout multiple images. And it's going to use these indicators to stitch those images together. So as you can see, the top example has a lot of unique visual features, whereas the bottom part of the example, just through the field, has fewer. So when you have fewer visual indicators for the software to utilize, we need to increase that overlap to help. Next slide, please. The next thing that we're going to speak about is the speed. So Measure Ground Control will automatically select a speed for you. You can override that speed, and it's going to use a couple things to determine the speed, and there are some things that you want to think about if you do decide to override the speed. The first one is we need to cover the way that the camera works is it captures the image. That data gets set into a camera buffer. It's basically fast memory. And then from the buffer, it will slowly, more slowly, begin to write to your SD card. And from the and what happens is if you move too fast, that buffer will fill up, that fast memory will fill up, and images will then get skipped. So they'll be written into the buffer, but they won't have time to write to the SD card, depending on the speed of your SD card. One thing to be aware of is when you are purchasing SD cards, kind of the listed speed on the SD card is typically the read speed. And the most important speed for using an SD card to capture data is the write speed, something to think about. The other part about selecting your speed is the motion blur. Typically, when you're flying the drone, we don't stop to capture an image. We're continuing along the grid row as we capture. And so a little bit of motion blur enters each image. Now, let's go to the next slide if we would. So as we're moving along and we're capturing the image, next slide, please. There we go. What we're doing is we're setting the shutter speed to 1/1000th by default. Now, occasionally you might want to override that, but we've put together a little chart here to help us determine when we might want to override it. So all these values are in meters in the chart below, and the blue line is moving at 5 meters per second, or roughly 11.2 miles per hour. So you could see anything over 40 meters, which is roughly 120 feet, 1/1000th speed is going to be fine. Now, if you really want to go a lot faster at, say, 10 meters per second or 22 miles per hour, then you need to probably increase that shutter speed or increase your altitude in order for that shutter speed to work. You can override these settings in Measure Ground Control. 95 to 98% of the time, the 1/1000th will work just fine for you. Let's go to the next slide, please. The next thing that we want to set, oh, I think we skipped one. Can you go back? No, I'm missing one. I guess the order's it's out of order. There it is. The next thing we want to talk about is altitude. So altitude will determine our final resolution of our data product. So the closer that we get to the ground, the higher the resolution that's being imaged. But there are some things that we have to think about when we're determining what altitude we want to use. Not only the safety of the aircraft and any objects that we could run into, but as we get closer to the ground, we also have less tie-in points. As we mentioned earlier, we would then need to increase the overlap to make sure we're getting enough tie-in points for the data to stitch together properly. And then again, you can see the resolution below the altitude. So at 300 feet, I think this was with the Phantom 4 Pro, we're getting about 3/4 of an inch per pixel. So each pixel would represent 3/4 of an inch on the ground. Let's go back to the direction. We can also adjust the direction of the drone. So as we're planning our flight plan, we can change at what angle or azimuth the grid rows are set up. Typically, this is more for making things more efficient, or maybe setting the beginning or end of the flight point or the start point near you or further away from you, depending on what you want to do. Sometimes, let's say you're imaging a solar farm, you might want to align the images along the solar array so that maybe the top of the image is constantly capturing the portion of the solar array that you want and is aligned.
I have a couple of questions before we even open this up to the Q&A side of it. So if you can help me, let's start talking overlap. So when we talk overlap, do the sensors that you're actually flying with have any effect on how you set overlap settings?
It won't have an effect on how you set the overlap settings, but what will happen is you'll see the kind of those green lines that we saw earlier, the grid rows, they will get closer together or further apart depending on what sensor you select in the software, because what we're doing is we're taking the different sensor sizes and the different focal lengths, and we're automating the adjustment of that flight plan based on the overlap. So when you can be confident that when you set it to say 80% overlap,
Right.
that no matter, as long as you're selecting one of the sensors we have in the system, which are, I believe all of the currently supported DJI sensors are in there, you can be confident that 80% of the image will be overlapped.
Okay, so you do need different overlap settings for different sensors.
Yeah, but we just take care of all of that for you.
Okay, so you smooth out that process.
Right.
Okay, so speaking back about altitude as well. So we have a question about the typography. How does that affect your map creation?
So typically, you're going to be mapping probably flat ground and you don't have to worry too much about it. But we do have a feature in the application that uses public data coming from Mapbox and other sources that will allow you to basically turn on terrain follow. Now you have to be very safety conscious when you use it because it is public data. But what it will do is it will, as it flies that path, it will increase the altitude and drop the altitude accordingly.
Okay,
And it will give you, oftentimes that gives you a better processing product if you have steep inclines and declines.
okay, and follow-up question, is the altitude based on the distance from the ground or is it measuring another metric?
So altitude will be relative, just like all DJI aircraft, it'll be from the point you take off. So if you set it at 150 feet from the top of a hill, the things you're imaging might be more than 150 feet. So you do have to be aware of that. Or if you're in a valley, you have to be aware of that for safety's sake.
Yep, always be aware of your surroundings. Okay, speaking about direction, how do the settings made available currently in the system ground control as we saw compare to others on the market?
Every piece of software is a little bit different. Some of them have a little more automation, some of them have a little bit less. We've always taken to make it available for the pilot to choose what they want to do. So we kind of expose as many controls as possible up front so that it's available for the pilot to decide, because they're the best, they're in the field, they're the best ones to decide what needs to be done to capture that location.
Okay, and just I think the last question that we have in speaking about data capture, when you, how can you prepare for offline data capture and ensure that those maps are then available when you're out on the field?
So we use Google Maps as our mapping framework. So the image that you'll see in the map will be tiles from Google Maps, and those will tile, or they will cache, excuse me. So basically what you want to do is when you have good internet connection, you want to open up the grid plans that you're going to be using
Okay.
and move around a little bit and let those tiles, those map tiles cache down locally. And then if you want to test it, you can always go into airplane mode and open those same missions again. But then you'll be confident that the tiles are there. So if you're offline or if you have poor cell service, you'll still have access to everything you need if you need to make in-field adjustments to the flight plan.
Okay, all right, great. That is all I have on a Q&A side, so we can definitely move forward.
Great. What I'm thinking, this is where we're going to do a live demo of everything Justin talked about. Can't do that, unfortunately. Apologies. It's a Zoom-ageddon of sorts going on. So what I'm thinking we'll do is we'll record this demo afterwards, and perhaps we can add this to the link so you can get a sense of what actually is going on live.
Yep.
In the meantime,
we'll insert all of the videos of the actual recorded demos on the email that you guys will all receive by early morning tomorrow.
Excellent. And if anyone has any questions, by all means, feel free to reach out, and we will explain to you what's going on in the live system. No problem. So what I'm going to do is move on to the next portion of our webinar, talking about data processing and analysis. The first thing to keep in mind is just what is it that we're going to be producing with this imagery. We have something we refer to as topo bundle, and that's topographic data products that are created from RGB imagery. And these are listed on the screen here. I'm going to get into details on each one of these as we go forward. Orthomosaic obviously is a data product that stitches together your RGB images that are individually collected and georeferences that orthomosaic can place with some caveats. Again, I'll get to that. DSM is a digital surface model where it's basically a gridded data product. Think of GeoTIFF files where each pixel represents an elevation. Contour map is also something you're probably familiar with. It's essentially a contour map shows similar elevation values connected by a line, right? You've seen it all in your hiking maps and everywhere else. It's a similar type of map. And finally, we also generate 3D mesh model, which is your a true 3D model in a point cloud, which is an interesting kind of byproduct of this type of data collection without anything like a LiDAR sensor and so on. I find it to be intriguing every time I look at it. Very quick note about resolution. Raster data product resolutions are automatically computed in our system. The engine we're using, which is Pix4D, automatically determines the optimal GSD based on the geometry of the image collection, literally where the images are located in space and various algorithms. So basically, and also takes into account things like elevation and topographic variation, and will automatically determine the optimal resolution. So typically you'll see resolutions ranging in centimeters range. It's the sample we showed today is going to show you, I'm proud to say, 1,000 better resolution than you'll see in, let's say, Google Maps and so on. When we look at contour maps, keep in mind that the resolution there is measured in vertical units, right? So this is going to be 1 meter vertical interval. That's what that means here. To prepare data for processing requires very little typically. You will simply collect the data, you'll copy it from your SD card, as Justin mentioned, and you will upload it to our system. And that's the end. That's really all you need to do. You just need to keep in mind that the acceptable file formats currently are only JPEG and TIFF, which is lion's share of what you're going to collect with a drone and not using kind of specialized sensors. That's all you really need to know. However, if you run into problems and issues, we'll cover that a little bit, you're going to need to look a little bit more into the images. And to set the stage for that activity, I'll spill some tricks about like what kind of tools to use to examine images themselves very easily. I'll talk about the preview and processing and visualization in our system and also in third-party viewers. Everything you're creating in our system you can download. You can simply download the data products you've created. If you're looking for a different experience of how to view these data products, you're looking to leverage additional analytical means, really sky's the limit because you can export the products very easily as standard formats and use them in third-party software. I'll also talk a little bit about just what you can do in third-party software, right? Those of you who are familiar with GIS will probably find this familiar, right? Those who are not, I'm going to tell you how to get started. So before I switch to the live demo, can I answer any questions?
We don't have any questions as of yet. Our watchers are liking the information that we're sharing, so I think we are good to actually move on to our demo.
Excellent.
Thank
I'm
you.
going to switch to a live screen here. My apologies if things flicker. And can you guys see my screen?
Yes.
Cool. All right. So just a second. Let me reorient myself with without Ben. Sorry.
No worries. He's sad that he's missing the webinar. Him and I are chatting. Technical difficulties. I think it's something that we're all experiencing at some point in time during this adjustment to this digital life.
That's right. Everything's virtual all of a sudden. All right. So let me just try to do this without the outline. If I go, of course, remind me, but I'm pretty sure I know what I want to talk about. So, all right. So let's just start at the beginning, right? So you're logging into Measure Ground Control. You've already downloaded all the imagery somewhere locally, or maybe it's still sitting on your SD card, and you have created, assuming a mission. If you have not created it, what you'll do in the software is you'll go through a quick process of creating a new mission, right? You'll basically fill out information about the name, location, the type of site you're using, address, and so on. We'll skip all this because I'm kind of impatient to get to the meat of this. Let's say we've created it. Voila, right? So here's the mission that's already created. Yes?
If you can just go full screen for us on this tab, that way we can see everything.
I can try.
If you click that.
I'm gonna have to jump a little bit back and forth, but okay. Let's do that.
Thank you.
All right, does that work?
Yes, beautiful. Thank you.
All right. So great. So this is what this is going to look like. You created a mission. We know where that mission is located roughly, what equipment's being used, and what have you, right? So you've uploaded your flight plan here already, and now you're finally getting to where you want to create data products. You could have already uploaded the images to what we call the image manager, the file manager. You can actually use this to store any files you want that are pertinent to your mission. You can upload pretty much anything. Just keep in mind that what you're going to process is going to be either in the root folder here or in a specified folder. The best practice here is to simply create a folder, something like this, right? And you'll basically go and you'll upload your files here, right? So that's really what that takes. And then you will end up with something that looks like this. So here's your mission. Here's all your files that are already uploaded there. You can actually view the files to verify that everything is looking good and so on. So you have the files on the system. At that point, what you're going to do is create the data product. You click this, you're presented with an option to either create a topo bundle or an IR related product, something we're working on right now, getting kind of a early heads up that this is in the works. This is an infrared data product, which is a very interesting kind of a paradigm. We're not going to get into that today. That's for another time. The topo bundle will contain everything I've already mentioned. It's going to contain the orthomosaic, digital surface models, contour maps, 3D point clouds, and meshes. And to get started, you'll simply select the folder you want to process from, right? This is what you're going to do. All the files that are in that folder are going to be selected. This says that 306 images will be processed from that folder. And then finally, you'll name it something. And let's just call it data product 1 or something like that. What happens next is you're going to get this preview. What this shows is the actual locations in real space where these images were taken. The purpose of this step is simply to eliminate what you don't want included in your stitched orthomosaics and other products. If you have some outliers you don't want included, you'll simply exclude them here. You'll just go, okay, like don't want this one, don't want that one, don't want that one. So if you wanted to, let's say in this case, create something that does not include water, right? Then you would simply do that. And everything else is included in processing. You hit next. What this is going to tell you, it's going to remind you what you're creating. It's going to tell you how many images you processed. If you're on a sort of paid plan, it'll remind you what, how many images you have available. And then from there, you'll hit submit for processing. And voila. So what happens is from there is the engine essentially starts processing your stuff, and you're going to receive an email notifying you that processing started, and stay tuned for the results, right? So when this is, if there's an error of any kind, it's going to send you a message. It's rarely that'll happen, but if it does, there's some exception handling things we can do. I'm going to talk a little bit about the quality report in a second. And then you kind of rinse and repeat, or you call us and we'll help you out. So that's what happens. Once this is processed, you're going to receive an email. I'm going to log in again here, and let's just say that this is an hour later when everything is already done. And we're going to go to the map component. So first of all, you'll see in your mission that this data product shows up and shows as processed, right? So like if we went here and looked at the status of the data products, you'll see that this is uploading right now. This is kind of in some processing state at the moment. You'll see that there is an ID associated with this. This ID is something you'd use if there's an issue. If there's some sort of a problem with your processing, then we need to know how to help you out, and that ID is the key to that help, right? And this is a pre-processed example that we created for this webinar. So that's what we're going to be looking at right now. Let's take a look here. So what we'll see is this viewer allows us to visualize pretty much everything we create in our system. We can visualize data products, we can visualize operational drone data, and all at the same time. So we're going to get into that. Your data product that has been created appears in the map like so. This is a very high resolution, very dense data product. This is going to end up being like a centimeter resolution, which is incredible. I just wanted to point out, like to brag about this. If you look at the satellite imagery, which in this case comes from Mapbox, from some sort of stitched layer that Mapbox supplies, you'll see that this is very nice for kind of overview purposes, but it's all very kind of patchy and low resolution. The best resolution you'll ever get from this maybe is 10 meters. And what we are looking at here is this, as this is already blurry on the sides and you can't really see anything, what we can do is we can continue to zoom in and getting 1,000 times the resolution here, right? So this is the principal difference between what the drone collected imagery looks like, and in contrast to what you can get with remote sensing platforms like satellites and so on. So
and
that's, yes.
On this screen, to zoom in, you're just zooming in and utilizing your mouse?
Yes, I'm just moving, exactly, right? Yep.
Okay, perfect.
So you can use these tools right here to do this, or you can use, I'm using a Mac, so it's a kind of a double pinch kind of a maneuver here. If you're really into tilt things, you can do things like that. It's not really interesting, but you can. And so on. So this is just really quickly about the organization of what we're looking at here. So first of all, you're seeing, check my time here, 2:40, great. And I just kind of zoomed out somewhere, sorry. There you go, back to this. The organization is very simple, right? So what you're seeing here is that this is our data product name that we created earlier in the flow. There is a ID that I mentioned before. This is something you want to always keep tabs on, and the date when this was collected, right? So right now we're looking at the ortho layer specifically. We also can visualize the digital surface model layer This is a just very kind of simple way to visualize. It's sufficient to appreciate the differences in elevation. All this is showing you really is just contrast and applying a color ramp to show that. It's a very standard way to visualize elevation model using a technique like this. And then lastly, contour lines, right? Contour lines will show you, these I think of them as just similar elevation values connected by lines. That's what a contour line is. This is something that we know to be a fairly mature technique out there. People have been using this technique forever in paper maps and so on. We chose to add this here as well. And this is something you could use in GIS as a vector file. What's important about this representation is that it's a vector way of representing elevation rather than a much heavier, bigger DSM file. So these are the key data products. I think a nice trick that you can do is you can actually go and find the flight plan that was used to create this, right? And you can overlay it on top. So this, if you care to know sort of how your drone flew, you can actually do this. This is, I'll correct myself, this is actually a plan prescriptively that the drone would fly. There's also a way to visualize the actual flight log of this, and I simply don't remember which one's which, so I'm not gonna fumble here. Anyway, so you can take all of this data and you can download it. That's the first thing you can do. You can just simply go to this ortho, hit download, it's going to save a GeoTIFF file. If I hit download here, same thing's gonna happen, GeoTIFF file is saved, right? And if you hit, if you select the contour file or any other vector type of data product like contour or even the flight plan, right? What this is going to save is a GeoJSON file that you can open in any GIS software or anything else that understands this standard format. So lastly, I'll mention this, is that this is just one way to visualize this. You can also use the visualization tool that our engine provides, which is a Pix4D engine. And what you do is you just select the entire project and click on this on this tool here, and it's going to give you a link to that. And if you click on this, what you're going to see actually is this, right? So now you're using a Pix4D viewer to visualize this. They have a 3D viewer. We don't yet. And this is something that you can use for 3D visualization. It's pretty cool, I think, to look at this. If you look, you can kind of pry into like that porch right there, which I find pretty fascinating, is that you can actually, with the type of capture that was done, is actually possible to see this. And in here, you can also use some simple tools like volumetrics and so on. Use these tools with a grain of salt, unless you're actually using ground control points to collect the imagery. You're likely not going to get reliable readings. This is okay for sort of what's called qualitative assessment, to give you an idea. If you wanted to get some measure of volume of something here, you'll see that you can. It's just you have to be careful with this stuff. Unless you're using ground control points, you're not really correcting for accuracy. So this is something you need to be at least cognizant about. And ground control points is something we're adding to our platform in a matter of weeks, I think now. So this is something we're currently developing. All right, so I'll go back to this just for 1 second. I forgot to mention the tools. You'll find that there's some really, really basic tools in here too that you can use. You can use things like, you know, your measure tools. You can also, what else can you do? You can do, I think, area, right? So this is all very rudimentary. Understanding that there's only so much you're going to want to do here, probably, at least for now. And you're going to want to take this into some sort of a GIS or whatever paradigm you're working in. I will talk a little bit to GIS tools, just because it's they're fairly standard, easy to use, and so forth, just in a second. Before I get there, I wanted to mention exception handling for 1 second. I'm going to go out of this mode here and show you an additional thing you're going to get as your project is getting done. So once your data product is created and you receive the message, you're going to receive this file. that is called the data quality report. This data quality report will tell you probably more than you ever need to really know. However, so you can use this for debugging, right? Like if something is going wrong, or you got an error, or something's blurry, or something else, this is the first place you're going to want to look at. There's plenty to learn here, but the key things I'll point out, which are important to keep in mind. One thing you're going to get out of this report is your automatically computed GSD, right? So you need to know what the actual resolution is of what you've processed. You're going to see this on this line. It's going to tell you. And in fact, you'll see that for this data product, for the demo that we've created, we get something like a centimeter resolution, which I think is pretty impressive. You'll also get some other facts about your data product here. You need to learn how to interpret this a little bit. You can sort of click on the knowledge base articles in Pix4D land and go read those. But also, if you're using our future feature of GCPs, ground control points, that information is also going to be listed here, right? So it also gives you a nice overview of what you actually have created, right? So just keep in mind that this is a useful feature for you. And very quickly, I'm going to speed up here, understanding I'm kind of running out of time. I can talk about this for probably like a week straight. I'm not going to. I'm just going to be done in 5 minutes instead. So if you wanted to actually see what's inside your EXIF tags in the images, right? So go to the site, goexiftool.org, download a command line tool that's going to allow you to open these files. And then you simply do this. You can point this tool to any file that you've collected, and it's going to give you all the metadata present in that file. Obviously, the key aspects of this, or key attributes in this file, are going to be things like elevation, GPS locations, relative and absolute elevations, and so on. And that's something that will serve as a key to explaining certain problems if you encounter them during processing, right? So that's something we normally deal with on your behalf, but also if you're like a curious techie like I am, then you'll, I think, find this interesting and useful. All right, so then lastly, I want to show you what happens if you downloaded the files and now what you can do with this stuff. For one, you can show, one of the things you download is an object file. This is what's called the mesh. There is a company, I forget what's called, maybe called Waveform. It's a really old company, used to exist, they actually created the standard like in the 80s. And amazingly, it's still being used today. And films like Godzilla was actually made using computer animation with these standards. So we're going to be opening these Godzilla object files here in a second, as soon as I find the tool. And there it is. So if Meshlab is a free tool you can download, I think they probably have an enterprise version, but you can open this if you want to tinker with the 3D representation and actually do interesting things like measurements, or even I think it allows you to make movies, fly-throughs and things like that. So that's something that you can readily use pretty much for free to get started. You can also use Mac's own fairly simplistic tool that allows you to preview object file and meshes. And if I can only find it, I will show you. Yeah, there it is. So amazingly, you can actually take a Mac native tool and open these 3D models. I'm not sure if you can do something like that on Windows, it's been a while, but you can certainly do that. And what I find the most interesting about the data we are exporting from the system is what you can do with it, right? So let's just say you're using QGIS or ArcMap or any really GIS tool. If you're familiar, you probably already know where this is going. If you're not familiar, then go ahead and go to QGIS.org, download this for free, and have at it. So what you're going to do here is simply open these files directly, and voila. So we have our stitched photo open. The applications here are numerous, obviously, right? So if we have reimaged the same area several times, then we can actually do things like change detection, simply visually, or tracking, or visual identification, you name it. So whatever you're using high resolution imagery for, you can do this. Here, it's very performant, fast. and so on. You can run a bunch of analysis on this. You can visualize your contours that I mentioned before. You can visualize the elevation model just the same as we did in ground control. And you can control all this. What's cool here is that you have a lot more control, obviously. This is a professional grade GIS tooling at this point. So you can really do anything you want here. You can change visualizations. You can reproject things, very importantly. You can do really anything. And just to concretize one type of analysis really quickly, I chose aspect as one of the things you can produce here. So we use our DSM geotip file as an input, and we're simply running the aspect calculation, which is a standard tool in QGIS, written by esteemed ex-colleague of mine, actually. So I'm quite familiar with this framework. And basically, what you're doing here is just selecting the source file, running the aspect calculation. The aspect, to remind those who forgot and explain to those who don't know what this is, it's basically it's a measure of orientation. Like, that's one way to think about it. The area pointing towards south versus north versus some other direction is what this actually is showing, right? So what this is showing is we have this red orientations towards the north and so on. So the objects on the ground, they have three-dimensional nature. We can visualize by aspect, and this is what this is doing. And this is just one type of thing you can do with DSM alone. Obviously, you can do a lot more. You can do, depending on what you're trying to do, you can do a lot of it here. All right, so I think that's all I wanted to say on the visualization part of it. And I think I'll just open for questions at this point.
Yes, and we've had a couple of questions coming in, so we'll just dive in. So Jameson is asking, will there be ground control point support and checkpoints?
The answer is yes. So we're working on that actively now, and we are looking to introduce ground control points very shortly.
Great.
Yes.
Great news. Okay. And we have Jeffrey's also asking, having worked with Pix4D in the past, will Measure have the Pix4D BIM capabilities like project timeline and volumetric comparison?
So there's certain feature set out of Pix4D we will adopt and are doing that already in our platform. And we're not trying to replicate everything that Pix4D does. So in all likelihood, some really specialized tools like that, we're not gonna implement. That would be my candid answer.
No worries.
But again, as if you wanted to do some basic volumetrics, you can actually use the tool that we already provide to do that. So some of it is already possible, but probably not gonna go to the nth degree of detail in this.
Okay, no worries. Regarding data processing, what is the difference between cloud and desktop processing, and when do you recommend utilizing one over another?
Oh, that's a good question. So we have made it, our vision is to really simplify processing, right? So what you're seeing in ground control is deliberately made to be extremely simple. And the amount of control, consequently, that you're getting over Pix4D processing is fairly limited. There are any number of edge cases and really sophisticated projects that could be done with Pix4D, being incredibly powerful and flexible software. We're finding that vast majority of what people do with basic drone data is pretty much similar, which is why we selected what we did. But for more specialized edge cases, certainly recommend using Pix4D desktop software, right? That's one difference. Another one is that in the cloud, everything is hands-free, right? Like, you upload stuff, voila, and just stuff comes out. If you want to get really granular or build extremely complicated data products, like, for example, things like radiometrically corrected imagery, or have like very high degree of control over accuracy you need to exercise, then you're probably best served to go to Pix4D desktop directly, right? And if not, then you can get by with a simple feature set we have, and also hopefully take advantage of ground control points for accuracy control, which will cover a lot of what we see mostly requested.
Okay, perfect. And to clarify what Jeffrey was asking, he's asking for that timeline. So I know that it's not ready yet, but he has a lot of work that he's doing on construction projects, and he's trying to find out if there's any more of a timeline.
Certainly, I'm going to go out on a limb and say this. Love these kind of questions. This is something we're literally working on right now. And I would say that it's on weeks, not months, that this is going to be out.
Okay. All right, there you go, Jeffrey. You heard it straight from Measure. And then we have one last question, unless anyone else wants to chime in. Can drones replace traditional inspection?
That's a really big question. So the inspection, so let's just cut to it. So survey grade accuracy, right, is something that is going to be possible fundamentally with introduction of ground control points with a lot of caveats, right? So once we introduce that, it becomes at least possible to control for accuracy. So you can actually properly tie the model you're creating to the earth and control that process. So in principle, it becomes actually possible for certain applications, but really it's a function of the accuracy requirements, right? And control over these accuracy requirements may not be possible merely with ground control points. And so there is not really a binary answer to that question. And if there is, if the person asking the question wants to share their experience with us or ask us some more questions, we're happy to speak directly as well, because we're always learning.
Okay. All right. And actually, there was one question that we answered right inside of the Q&A chat that I wanted Justin maybe to answer out loud for all of our other guests. The question came from Joseph, and he asked, can you pre-plan your flight on a PC, laptop, or laptop before going to mobile? So Justin, if you can just elaborate your answer there live for us, it'd be greatly appreciated.
Sure. Yes. So the answer is yes. Back when we were seeing the platform, when Ilya was sharing the platform where you set up your data product in the mission, there is also a button to the left of that that says create flight plan, and you can actually create your flight plans in a web-based editor, and it looks very similar to the mobile-based app. The controls are all in the same place, and it's all the same controls. And then what will happen is you'll save that, it becomes part of the mission, but it will also automatically sync to the mobile application. So the next time you launch a mobile application, it will sync down. You'll be able to pull it up right in the mobile application, then go out into the field and utilize those desktop plans.
Okay, perfect. It seems like you guys have tried to think about everything, making it just go from the seamless cloud-based, being locally on a desktop, or analyzing it through mobile. You guys have thought of it all. So we do have one last question, it looks like. So what is the best practice for number of ground control points when planning a flight based on an area?
Sure, I'll try to tackle this. So purely from a geometric standpoint, the number of ground control points required, absolutely required, is 3. The reason why that is, there's a mathematical reason, obviously, something called affine transformation. It's only 3 points are required to rotate and scale an image into place in order to georeference it. So that's 3. Best practice says that you need to collect either 5 or more, but not more than 10. And the way that you decide to distribute these ground control points on the ground is as far uniformly away from each other as possible, number 1. And number 2, not quite near the edge of your area of interest. The reason why is because the drone is going to have probably the lowest overlap towards the edges, fairly common, and you don't want that ground control point to be in kind of the red zone. So it's somewhat away from the edge, right? And be something between 5 and 10.
All right, perfect. Thank you. And that one was for you, Abdul. All right.
Excellent.
Q&A.
All right. Do we have any other questions before we go to our plug?
It looks like we're all set. And anyone else, if you want to get in those last minute questions before we move on to our next the next section and do our kind of wrap up here, feel free to chime in now. All right, I think we're good to go.
All right. So I'm just going to cover this real quick. We are also, if you're ever out in the field and you need help from a colleague, or you just want to, or you need to work with a customer, we're working on a remote collaboration tool called ChatPixel. And it's basic, simple video collaboration. It works with DJI drones. So what it does is it will do low latency, sub 1 second latency streaming of your video image from the drone to either another mobile app or a web app. And it also allows bi-directional annotation, so the remote viewer can annotate, and also the audio bridge, so you can talk to each other via voice. And what we're doing is we want to invite you to a free trial of our ground control platform using the link in the next slide. And the first 50 people that join up will get also an invite to the beta test of ChatPixel if they're interested, and also receive a $50 Drone Nerds gift card.
They will. Yes, they will. And that was ChatPixel for those that are curious. And thank you. And then I also, thank you so much for that, Justin. And I just wanted to, before we close out here, kind of just recap and remind everybody of what we've talked about here today. And please make sure right after you log off, a survey will pop up. If you can share your feedback, we apologize for those technical difficulties in the beginning, but really give us feedback as to, was the information useful in your current position that you're doing? Is there another topic? Would you like a deeper dive? Were we technical enough for a tech talk? So share those concerns with us, or share that great feedback that you loved the entire webinar. But these best practices across the mapping process. Real quick, flight planning to ensure the best result, always. You want to make sure that your camera adjustments are made for the highest quality imagery, and tools and settings to best utilize processed maps and other data products are available to you and accessible. Speak with a Drone Nerds representative and we can help you get started. We will send out an email that recaps everything you've seen here today. We will also include the link to sign up for that $50 gift card with the 14-day trial for Measure. But Ilya, thank you. Justin, thank you so much for joining us. And to all of you that tuned in, thank you, and we hope you stay safe and have a great rest of the day.
Thanks, everyone.
Thank you,
Take care.
everyone.
Bye.